Hello all and welcome to this final lecture on vectors. Within this video, we are going to cover the topic of basis vectors, orthogonal vectors and orthonormal vectors. So let's start with basis vectors first. And if we go by the definition, then it says that basis vector can be scaled to represent any vector in a given vector space. Now let's try to understand what does that mean. So for explanation purpose, I have considered these two vectors here, which is vector I and vector j. Vector I has two elements, 1 and 0. So it is 1 points towards the x-axis and 0 points towards y-axis. Similarly, the vector j has two elements, 0 and 1, which means 0 points towards x-axis but 1 points towards y-axis. And if we pay attention, then these two vectors, vector I and vector j, are combinedly representing this point in this 2D space. However, if we go by the definition, then it says that a basis vector should be able to represent any vector in a given vector space, which means although this vector I and vector j are representing this particular point in this 2D space, but it should also be able to represent any given point in this 2D space. For example, these two vectors should also be able to represent this point right here. So how can we do that? I have created this vector v by doing some manipulation on vector I and vector j. And to be precise, I have multiplied vector I with 2 and I have multiplied vector j with 0.5. So as we know that we have the elements 1 and 0 in vector I, and if we multiply this by 2, then we will get 2 and 0. And similarly, we have elements 0 and 1 in vector y, and if we multiply this by 0.5, then we will get 0 and 0.5. And if we add these two products like this one and this one, then we will get 2 and 0.5, and this will be the value of this vector v that we have considered over here. So 2 points to the x direction, which is here, and 0.5 to the y direction, which should be somewhere here. And as we can see that vector v is representing this point over here that we initially wanted to represent as per the problem statement. So we have seen that how this vector I and vector j, which was initially representing this point, is also able to represent this point after some manipulation. Hence, vector I and vector j are basis vectors because as per the definition, it is able to represent any point in a given vector space. And now since we are already familiar with basis vectors, let's try to understand what are orthogonal vectors. So two different vectors, let's say vector A and vector B, are said to be orthogonal if their dot product is equals to 0. And this condition has to be satisfied in terms of an orthogonal vector. So for example, if we take these two vectors, vector I and vector j, and we try to calculate the dot product between these two vectors, then we will get 0 as an output. We have already covered the topic of dot product within this playlist. So I suggest that you try to calculate the dot product between these two vectors, and I assure you that you will get 0 as an output. Secondly, both the vectors should be at 90-degree angle to each other. And as we can see, vector I and vector j are exactly at 90-degree angle to each other. So this is the second condition being satisfied. Thirdly, in a given n-dimensional vector space, there could be max to max n mutually orthogonal vectors, which means if we talk about a 2D space, then it could have max to max 2 orthogonal vectors like this and this. But if we talk about a 3D space, maybe something like a cube, which I will try to draw here. All right, not perfect, but good enough. So it will have max to max 3 orthogonal vectors. First in the x-axis, second in the y-axis, and third in the z-axis because of the height. And as we know so far that humanly it is very difficult to visualize a space or tensor above 3 dimension, but still you need to understand that a tensor up to n dimension will have max to max n mutually orthogonal vectors. And the last thing is that orthogonal vectors with unit norms are called orthonormal vectors. So we have already covered the topic of norms within this playlist, and we have also covered what are unit norms. But still, just to give you a high level overview, these two orthogonal vectors, vector I and vector j, if we try to calculate its magnitude, then this value will also be calculated as 1. And in that case, these two vectors becomes orthonormal vectors. For example, basis vectors can be considered as orthonormal vectors because it satisfies all the conditions. If you take the dot product, you will get 0 as the final output. They are always perpendicular to each other, which means at 90-degree angle. And if you calculate the norm, then you will get the magnitude or output as 1. Okay, so that is it for today's lecture. I hope that you found it useful. If yes, then please consider supporting the channel. Please drop a like below and share your feedback in the comment section. And going forward within this playlist, now we are going to learn about matrix and its properties. Thank you very much for your time. See you in the next lecture.